Functions, domain and range. Domain is the complete set of possible values of the independent variable, while the range is the complete set of all possible resulting values of the dependent variable. So for the domain, we look for the values of the independent variable which we can substitute into the given function without breaking any mathematical rules. Range, then, we look for the values of the dependent variable which we get by substituting possible values of independent variable into the given function, again without breaking any mathematical rules. Here are the two main rules which we must keep in mind. The first one, negative rules under the negative numbers under a square root. For example, we know we cannot have a negative numbers under the square root. So if we have, for example, a function f at x equals y, which is same as y, is square root of x plus 5, then we know whatever number is inside the square root has to be positive, more than or equal to 0. So we say then x plus 5 is greater than or equal to 0. Simplifying for x, then subtracting both sides by negative 5, we can say then x has to be greater than or equal to negative 5. So then the domain of this function is x is element of all real numbers such that x is greater than or equal to negative 5. X belongs to real numbers such that x is greater than or equal to negative 5. Okay. So to note that no matter what we put for x within given domain, the y value cannot be negative in this case. The smallest it can be is 0. So no matter what I put for x, I will get square root of some number which will always be 0 or more. So the range in this for this function will be y belongs to R, y is element of real numbers such that y is greater than or equal to 0. Okay. So negative numbers inside the square root is not possible. So whenever we see a square root function, we will say whatever is inside the square root has to be greater than or equal to 0, and then we'll solve for x. Okay, that's to find domain. To find range, if we have a positive square root, it will be always y greater than or equal to 0. If there was a negative in front here, then the range will be y less than or equal to 0. Okay. Now 0 denominators. We know a number in the denominator cannot be 0. If it is 0, it's undefined. So we cannot have a denominator equals 0. So if I have a function f at x equals 4 divided by x minus 2, we need to make sure denominator does not become 0. So we will say x minus 2 cannot be 0. If I were to solve for x from there, bringing 2 to the right side or adding 2 on both sides, we get x cannot equal 2. So then the domain for this function is x belongs to R, or x is element of real numbers such that x can never be equal to 2. So it can be anything else other than 2. Now, how about the range? So we cannot have x equal 2. But what are the restrictions on y values? If we have y equals 0, for example, we will get 0 equals 4 divided by x minus 2. When we reorder this, we get 0 equals 4, which is not possible. So the range for this function will be y is element of real numbers such that y cannot be 0. Okay. So y here will not be able to be 0. If there was a number here at the end, like plus 1, plus 2, then y will not be able to that number. So if it was plus 1, it will be y cannot be 1. If it was a minus 2 at the end here, it will be y cannot be minus 2. So it's like this. If it was minus 2, y cannot be minus 2. If it was plus 1, y cannot be plus 1. Because there is no number, it's kind of plus 0. We say y cannot equal to 0. Okay. So these are the two special rules, one with the square root, one with the 0 in the denominator. So when we think about domain and range, we have to think about what are the restrictions on independent variable and what are the restrictions on dependent variable. Restrictions on independent variable will be domain. Restrictions on the dependent variable will be range. Okay. That is domain and range.